Welcome to Sleep Library, where we tell quiet stories for curious minds that need a little rest. Tonight, we'll be drifting through the thick, golden clouds of Venus, a planet that looks peaceful from afar and isn't. Before we begin, if you'd like to help the library grow, you can gently tap subscribe, give this video a sleepy little like, and let us know in the comments where you're watching from tonight. No pressure, just if it feels nice. Venus has always been a bit of a show-off. Up there in the twilight sky, glowing with a brightness that outshines most stars, she arrives just before night falls, or sometimes just before the morning wakes. She's dependable like that, the kind of cosmic friend who turns up to dinner dressed in gold. It's no wonder the ancients thought she was special. The Babylonians named her after Ishtar, the goddess of love and war. The Greeks too gave her a divine name, Aphrodite, and the Romans, never ones to miss a branding opportunity, went with Venus. So, we ended up with a planet named after love, which, as it turns out, is rather ironic. Because Venus beneath her golden glow is one of the most violently unloving places in the solar system. If planets had personalities, Venus would be the one who looks dazzling at a distance, but turns out to be deeply chaotic when you get too close. She's beauty without mercy, a siren with a sulfuric perfume. But long before we knew any of that, before we could even point telescopes at the sky, she was just a bright mystery, a wandering star, the brightest object in the heavens after the sun and the moon. Ancient civilizations watched her rise and fall, assigning her stories and meanings and subtle moods. In ancient Mesoamerica, Venus was a god who brought war and timing. In India, she became Shukra, a celestial teacher. In modern times, she's still something of a celebrity, the third brightest natural object in Earth's sky, and still a favorite for stargazers. Of course, appearances can be misleading. Venus may twinkle like a jewel in the dusk, but her reality is much less hospitable, and we curious, slightly arrogant earthlings eventually got around to finding out just how unwelcoming she really is. It took some time. Through the early telescopic age, astronomers guessed she might be a lot like Earth. Similar size, similar mass, shrouded in clouds, which some took to mean she might be rainy and lush, a swampy twin with frogs, perhaps. This was, scientifically speaking, adorable. But once we started sending probes, mechanical scouts from our little blue world, Venus began to reveal herself, slowly, and not without some drama. It turns out she was hiding secrets, and most of them were hot. Literally hot. Not warm summer's day. Hot. Not even Arizona in July hot. We're talking molten lead melting, flesh vaporizing, electronics destroying hot. And yet, she still shines in the night sky, pretending to be something gentle. That's Venus for you. Perhaps there's a lesson in all this, about appearances, or about curiosity, or about how nature doesn't really care what we name things. Still, it's comforting to imagine ancient astronomers squinting up at her light, unaware that they were admiring a world so intensely hostile it makes our worst deserts look like luxury spas. Venus is an enigma in pearls, a jewel with a temper. And now that we know a bit more about her, now that we've sent machines to peek under her cloudy veil, we can begin to tell the quiet, smouldering tale of what would happen if you tried to visit. Spoiler, you wouldn't survive. But don't worry, we're not here to panic. This story isn't about fear, it's about wonder, the kind of wonder that glows softly in the night, even if it's surrounded by acid clouds and 900-degree heat. So let's drift gently, without hurry, into the thick yellow atmosphere and see what lies beneath. Let's begin softly at the edge of the sky. Imagine floating down from space, slowly, like a feather drop from the hand of some absent-minded cosmic child. You descend through a gauzy veil of pale clouds, and at first, it's oddly peaceful. There's a golden hue, a thick, sleepy stillness, the kind of place where light diffuses, not sharply, but with the blur of memory. But you've only reached the upper atmosphere, a few dozen kilometers down, and the welcome starts to fade. Because Venus, quite literally, has the worst weather in the solar system. The kind of atmosphere that would not just ruin your day, it would dissolve your day, along with your spacecraft, your suit, and anything else you brought with you. At the top, the air is thin and frigid. It's the one part of Venus that isn't unbearably hot, a deceptive grace note, like a cool breeze before a volcano erupts. The clouds here are made of sulfuric acid, suspended in thick, swirling layers. Not mist, not fog, acid. You may remember sulfuric acid from your school chemistry lab, usually in a little bottle, handled carefully. Here, it hangs in the sky like fog over a haunted moor. It's one of those facts that's quietly absurd. The entire planet is wrapped in clouds that would strip paint and melt flesh. And yet, it still looks beautiful from a distance. You might wonder why a planet would dress itself in acid clouds. It's a fair question. The answer, loosely, is chemistry and bad luck. Venus's atmosphere is a thick soup of carbon dioxide, about 96% of it with traces of nitrogen, and tiny droplets of sulfuric acid suspended like poison snowflakes. These droplets form when sulfur dioxide, which volcanoes on Venus seem to burp out in considerable quantities, reacts with water vapor and sunlight in the upper layers of the atmosphere. The result is a yellowish mist of airborne acid. Charming. Beneath that acidic haze, the atmosphere gets thicker, much thicker. The pressure climbs, the temperature rises, and the clouds become more opaque, less like fog, more like pea soup stirred by a hurricane. And yes, about those hurricanes, winds on Venus can reach speeds of over 360 kilometers per hour, particularly in the upper atmosphere. That's about as fast as a Category 5 hurricane here on Earth, except on Venus, it's not a passing storm. It's constant, global, eternal. The entire upper atmosphere rotates around the planet faster than the planet spins itself, a phenomenon scientists charmingly call superrotation. So not only are you drifting down through acid clouds, you're being whipped sideways at speeds that would lift a house clean off its foundations. It's rather like being dropped into a boiling vat of salad dressing and then flung around by a celestial food processor, except less nutritious. Now, for a moment, let's consider rain. Venus has rain technically. The clouds are thick with acid droplets, and in some layers the droplets coalesce and fall just like on Earth. But Venus's surface is so incredibly hot that the acid evaporates long before it reaches the ground. So the rain falls, but never lands. It's a poetic sort of futility. Clouds forever weeping into a furnace, with nothing below to catch their tears. Somewhere around this point, any human-made probe that's been gently lowering through this sulfurous stew begins to heat up. Its metal frame creaks, its seals strain. Electronics that work perfectly in a clean lab back on Earth begin to fail. Most landers don't survive more than an hour or two on the surface, if they make it that far at all. In a way, Venus is a test of optimism. Every probe we send is built with the quiet hope that this one might last just a little longer, and they do, sometimes, by a few minutes. eventually, the acid, the heat, the pressure, they all win. And still, up in the sky, she twinkles. This is the contradiction of Venus. From afar, she looks like the calmest of places, but up close, she's chaos under glass. A lesson in how nature doesn't care what we think is pretty. Still, drifting through her clouds, with their yellow shimmer and ghostly winds, one might feel a strange kind of awe. Not fear, not really, just the quiet, unreasonable vastness of it all. A planet can wear acid like a coat and still look like a goddess from Earth. That's the kind of universe we live in. Suppose, for a moment, that you've survived the acid clouds, that your descent has brought you down through layers of golden mist, through swirling sulfur, through the lightning-haunted skies of a restless planet, and now gently, impossibly, you reach the surface. The first thing you would notice, assuming you could notice anything at all, is the weight, not of your own body, but of the very air around you. It presses on you with a kind of slow, smothering certainty, the way water presses on a diver at the bottom of the ocean. But you are not underwater. You are on dry land, or what passes for land here. On Venus, the atmosphere is so dense, so crushingly thick, that standing on the surface is like standing 900 meters below the ocean on Earth. That's the pressure equivalent, about 92 times the atmospheric pressure we're used to. To put it more plainly, if you were foolish enough to step onto the surface of Venus without protection, you would be flattened instantly, not exploded, not boiled, just calmly and firmly pancaked. It's not a violent kind of destruction. It's more inevitable, like gravity or bedtime. Even metal feels the weight. Landers sent by the Soviet Union in the 1970s and 1980s, those brave, wheezing machines were crushed and baked by Venus in under 2 hours. Some melted, some collapsed. One even managed to send back a few photos, right before the heat and pressure did what Venus always does. It ended the visit. And then there's the heat. 465 degrees Celsius. That's the surface temperature of Venus. Hot enough to melt lead. Hot enough to vaporize many common materials. Hot enough that the phrase room temperature begins to sound like a joke. And yet, this heat is not caused by proximity to the sun. Venus isn't much closer to the sun than Earth is. No, Venus is hot because she holds onto heat, like a planet-sized greenhouse with the windows sealed shut. Her thick carbon dioxide atmosphere traps solar energy with cruel efficiency, letting sunlight in and refusing to let the warmth escape. It's called the runaway greenhouse effect, and Venus is the cautionary tale of what happens when it goes unchecked. Earth has a greenhouse effect too. We rather depend on it. But Venus has taken it to an extreme. There's something strangely comforting in her overcommitment. She doesn't do things halfway. Back on the surface, if you were somehow inside a pressurized, heat-resistant shelter, and you peeked outside, you would see a landscape of soft orange light. The sun is up, technically, but it doesn't shine. It glows weakly through the dense clouds. The rocks are dull, dusty, and faintly yellow. Everything looks washed in sepia, like an old photograph left in the sun too long. The wind here is gentle. After the violent swirls of the upper atmosphere, the surface is oddly still. The air is so dense that sound might carry well, but there's nothing to make sound. No birds, no breeze, no life, just the quiet weight of the air. And you, if you're still imagining yourself here, would feel none of it, because you would be a puddle, or a memory. But don't let that disturb you. Venus means no harm. She's not cruel, only consistent. She is a planet that has chosen extremes, and in her quiet, baking stillness, there is something strangely soothing, a kind of geological meditation, mountains that haven't moved in millions of years, rocks that lie in silence, skies too thick for starlight, no change, no motion, just pressure and heat and waiting. Some of the Soviet landers were given names like Venera, which means Venus in Russian. It's fitting. They came to meet her, briefly, politely, and then they were gone like whispers in a furnace. So if you were ever tempted to visit Venus, to stand on her soil and look around, know this: you could bring the best suit, the best technology, the cleverest engineering Earth could offer, and you would still last just a little while longer than a soft-boiled egg. But then again, there's something peaceful about limits, about places where humans aren't meant to go. Venus doesn't keep us out with violence. She simply exists as she is, perfectly hostile. Time on Venus has a sense of humor, not a loud, boisterous humor, more of a dry, slow-burning joke, the kind you don't fully understand until much later when you're brushing your teeth and suddenly chuckling. Because Venus spins at its own pace, which is to say, it barely spins at all. To be precise, one day on Venus from one sunrise to the next is longer than its entire year. It takes about 243 Earth days for Venus to rotate once on its axis, but it orbits the Sun in just 225 Earth days. Let that sink in like warm tea. A year on Venus is shorter than a day. You could, in theory, celebrate your birthday before you finish breakfast. Of course, timekeeping on a planet like this is a purely academic pursuit. There are no people here, no to-do lists, no schedules to keep. And yet, we can't help ourselves. We try to apply Earth's tidy calendar to a place that absolutely refuses to cooperate. If you stood on the surface of Venus in your imaginary heat-proof cocoon, you wouldn't notice the Sun moving across the sky in any familiar way. For one thing, Venus rotates backwards, relative to most other planets, including Earth. So the Sun would rise in the west and set in the east slowly, like a hesitant guest at a dinner party. And because of the planet's sluggish rotation, you could spend weeks watching the faint glow of sunlight creeping through the acidic clouds, wondering whether the day had begun or whether it was still stretching out its fingers. But the strange tempo doesn't end there. Because Venus's rotation is not just slow, it's also deeply stable. Unlike Earth, which wobbles slightly on its axis, a charming flaw that gives us seasons, Venus holds its position with stiff persistence. No tilt, no wobble, no seasons. It simply turns, once every 8 months or so, leisurely, patient, like a planet that believes there's absolutely no rush. It's tempting to imagine what human life would look like under such a rhythm. Mornings that last for weeks, sunsets that stretch into months, sleep schedules abandoned entirely. Would we even bother with clocks? Perhaps we'd invent new kinds of time, not hours or minutes, but light moods. Oh, it's lemon glow time now. Wake me when the sky goes to honey amber. But Venus offers no comfort for dreamers. Her skies are too thick for sunlight to pierce directly. So even if you waited patiently for the sunrise, you wouldn't see it, just a gradual brightening. The way morning feels when you're indoors, curtains drawn. It's a kind of timelessness that borders on myth. And yet, scientists have measured it precisely. We know the numbers, the rotational period, the solar day, the oddities of backward spin. It's all catalogued neatly, even if the experience of time on Venus would be anything but neat. In this way, Venus defies not just survival, but comprehension. She takes our most basic assumptions, gravity, temperature, time, and tilts them sideways. And she does it quietly, without showing off, just sitting there orbiting the sun, glowing gently in our evening sky, like nothing's out of the ordinary. Maybe that's the lesson. Not everything needs to move fast. Not everything needs to follow a rhythm we understand. Some things like Venus just take their time. On most planets, if you want to understand their past, you look for scars, craters, rifts, basins carved by ancient impacts or tectonic shifts. The surface of a planet is often a record of its traumas, like wrinkles on an old face, each one quietly telling the story of what happened long ago. Venus, of course, does things a little differently. She wears her past vaguely. Look closely, or rather, send radar signals carefully through her cloudy veil, and you'll find a surface that is surprisingly smooth, not polished, not glassy, but lacking in the sheer number of craters you'd expect for a planet that's billions of years old. This tells us something peculiar. Venus has resurfaced herself. At some point in the not-so-distant geological past, great swaths of her crust melted, shifted, or erupted, burying whatever marks time had left behind. Not a facelift exactly, more like pouring fresh lava over an old painting. And there are volcanoes, many of them. Thousands, in fact. Small ones, massive ones, shield volcanoes and pancake domes. Venus has more volcanoes than any other planet in our solar system. Some are enormous, stretching hundreds of kilometers across. Others are like little blisters on a very hot face. But here's where it gets quietly interesting. We don't know if any of them are active. It's not for lack of trying. Scientists have spent decades peering through the thick clouds with radar and infrared sensors, looking for clues. And sometimes they find them. A patch of surface that seems warmer than it should be. A plume of gas that suggests something stirred below. A small feature that, on closer inspection, wasn't there a few years ago. These are not smoking guns. They are geological whispers. Venus might be volcanically alive, just not loudly so. No Mount St. Helens moments. No ash darkening the sky. Just the slow, ancient churn of a planet that breathes magma beneath its quiet skin. It's hard to imagine a more introverted kind of tectonic activity. If Earth's volcanoes are extroverts booming, spewing, making headlines, Venus's are the opposite. If they're erupting, they do it politely, modestly, or perhaps they're simply waiting. We're not sure. But the landscape certainly looks volcanic. There are lava plains that stretch like old carpets, ridges and fractures like stress lines on glass, and structures with charming names like coronae, which are vast circular features, possibly formed by upwellings of hot material from beneath the crust. Some coronae are hundreds of kilometers wide. They sit there quietly suspicious, like crop circles left by lava. And every few years someone finds a little more evidence. A subtle thermal anomaly, a change in infrared glow, a slightly shifted landscape. Each clue is met with cautious excitement, like spotting footprints on a foggy trail. But Venus, as always, remains elusive. She tells us only what she wants, and even then, only in riddles. Still, the idea of a volcanically active Venus is oddly soothing. It means she's still alive in a way, still moving, not just a fossil in orbit, but a dynamic world with a molten heart, not lifeless, just lonely. And if the volcanoes are still awake, even a little, perhaps the planet is dreaming. Of what, we can't say. But there's something gently compelling about a place that simmers rather than shouts, that warms from within, that hides her fire behind clouds of gold and acid. Venus may not have earthquakes or continental drift like Earth, but she has her own tempo, her own geologic breath, slow, hot, quiet, and perhaps that's enough. Somewhere, right now, someone is planning a mission to Venus. Not a tourist, of course, probably not even a crewed voyage, just a machine, a well-insulated, brave little probe, carefully engineered to last a few precious minutes longer than the last one did. We know how the story ends with melting parts and fading signals, and yet we keep sending them. Not because we expect Venus to suddenly become welcoming, but because we're curious. Despite everything, the heat, the acid, the pressure, Venus still draws us in. There's something stubbornly romantic about the idea of visiting. Perhaps it's the irony of her name, or her eternal shimmer in our skies. Or maybe, just maybe, it's the whisper of possibility. Because there's one region of Venus that's almost survivable. About 50 kilometers above the surface, in the upper atmosphere, the temperature and pressure drop to levels that are strangely similar to Earth. It's still not breathable. The air is full of carbon dioxide and acid, but the pressure is tolerable, the temperature merely warm. And so, naturally, someone had an idea. Floating cities. Yes, cities suspended in the clouds of Venus. Picture it. Vast, helium-filled balloons carrying human habitats, drifting gently in a sea of golden haze. No landings, no walking on lava rock, just floating, quietly, above the storm. Science fiction? Certainly, but not entirely unthinkable. Helium or hydrogen balloons could provide lift in Venus's thick atmosphere far more easily than on Earth. The acid could be repelled with certain materials. Solar energy is abundant up there more than on Earth, in fact. And perhaps most importantly, it's calm. Unlike the surface, the upper atmosphere doesn't roast you instantly. It doesn't squash you. It just floats, like tea steam on a warm evening. It would still be dangerous. Life inside a floating city would be confined, carefully managed, endlessly monitored. But compared to the furnace below, it's practically a resort. This vision of cloud cities and soft-colored skies has been quietly discussed in space agencies and speculative papers, not as a plan for tomorrow, but as a dream, a maybe, a someday. And dreams, as it turns out, are stubborn things. We've been dreaming about Venus for centuries. Long before we knew what she was, we saw her light and imagined gods, goddesses, lush lands, and cosmic mirrors. Even now, knowing what we know, we still look up and wonder. Because Venus is more than a planet. She's a paradox. A world that glows like a pearl but cooks like a kiln. A sphere of death that still stirs visions of beauty and life. A warning, perhaps, of where greenhouse gases can lead, but also a reminder of the strange persistence of hope. We are, as a species, remarkably good at wanting things we can't have, sometimes foolishly, sometimes beautifully. And Venus, hot, hostile, and heartbreakingly lovely, is the perfect example. So perhaps, in some far-off future, people will live above her clouds, not on the surface, not yet, but up high, sipping coffee in climate-controlled domes, watching golden lightning flash silently across the sky below. And maybe they'll laugh, softly, at the irony of it all. That we found a way to live in the most unlivable place, just by not touching it. Until then, Venus will remain what she has always been. A shimmering mystery, a beautiful warning, a celestial contradiction. And for those of us tucked warmly in our beds, she will keep shining in the evening sky, watching, spinning slowly, waiting. Not for us, but simply because that's what she does. If you could smell Venus, it would likely be your last sensory experience. Not because the scent itself is deadly, though it's far from pleasant, but because inhaling even a trace of that heavy, acrid atmosphere would sear your lungs into silence. Still, let's pretend gently that you could smell it safely. Just a small whiff, a cautious sniff of air from a world that does not host noses. Venus smells like chemistry gone wrong. Not the sterile, lemon-scented kind found in school labs, but the thick, primitive stench of elemental soup, raw and unfiltered. A bouquet of carbon dioxide, sulfur dioxide, and the faint, ghostly trails of hydrogen chloride. To the human nose, it would smell like rotting eggs that someone boiled in metal, with a hint of fireworks and a sharp sting in the sinuses. It's not personal. Venus isn't trying to be offensive. It just happens to be full of things that Earth keeps in tightly sealed containers. Start with the carbon dioxide, the main ingredient. On Earth, CO2 is subtle. It's what plants crave, what fizzes your soda. But on Venus, it's the air itself. Not a trace gas, but the overwhelming majority. And carbon dioxide, when compressed and heated, doesn't just sit there politely. It becomes heavy, oppressive, like trying to breathe soup. Then there's sulfur dioxide. It's what gives Venus her yellow tint and her particular aroma. Sulfur dioxide smells like burnt matches, like the smoke that rises after someone lights a firework indoors. It's a scent that doesn't ask your permission. It grabs the back of your throat and stays there. On Earth, it comes from volcanoes and exhaust pipes. On Venus, it comes from the very sky. The clouds are full of it, thick, smoggy curtains of yellowish mist, suspended above the broiling ground. Mix in a little hydrogen chloride, sharp, pungent, slightly industrial, and you start to get the full perfume of the planet. Not floral, not fresh, but certainly memorable. Scientists, of course, don't use words like reek in their papers. They talk about molecular weights, absorption spectra, and atmospheric models. But behind the math, there's a kind of olfactory horror show happening up there. If Earth's atmosphere is a clean, breathable lullaby, Venus's is a chemical protest song. Hot, loud, and layered. Interestingly, some parts of the Venusian atmosphere are mildly ambiguous. Scientists have detected chemical signatures in the clouds that don't completely make sense. At one point, there was excitement about phosphine gas, that on Earth is often associated with biological activity. For a moment, the world leaned in. Had we found life? Or at least the trace of something odd? It turned out to be uncertain. The data was reanalyzed. The signal, perhaps, wasn't what it seemed. As with many things on Venus, we were left with more questions than answers. But even that uncertainty, that whisper of possibility, added another strange note to her scent. Because the chemistry of Venus is not simple, it's dynamic. There are layers upon layers, like a sour parfait, each one swirling with different pressures, temperatures, and compositions. In some regions, the sulfur dioxide is rising. In others, it seems to sink or vanish. The clouds churn and react. Molecules form, break, and reform. The planet is not just hot. She is busy. Some scientists have tried to model how this atmosphere might evolve over time. If Venus were cooled slowly, hypothetically, over centuries, what would remain? Would the clouds condense? Would the rains finally reach the ground instead of evaporating mid-fall? What would the smell of Venus be? After the fire? We don't know, and we're unlikely to find out anytime soon. Sampling the air on Venus is a logistical nightmare. Most landers don't make it more than a few breaths worth of time. And balloons, those lovely floating laboratories, have only been tested briefly. Still, the fantasy lingers. A little weather station drifting high in the upper cloud decks, measuring wind speed and acidity. Perhaps it has a tiny sensor, a synthetic nose, gently analyzing each chemical kiss in the air. And perhaps, in some future far softer than ours, there will be explorers who carry a vial of Venusian gas collected and sealed as a curiosity. They'll open it under glass, far from lungs and senses, and say, "Ah, yes, that's what a planet smells like after 4 billion years of being slowly cooked." The poetry of planetary scent is rarely discussed, but it's there. Mars smells like iron and dust. Jupiter of ammonia and lightning. Earth, of course, smells like life, like rain and leaves and oceans and people. Venus smells like the absence of all that. She is the scent of what happens when you take a planet almost like Earth and turn up the heat. Let the volcanoes roar. Let the oceans boil away. Let the sky turn yellow with gases that once rested deep in stone. She is the smell of a world undone. And yet she still glows, still dances in our twilight, still captivates. There is something quietly beautiful about a place that can be so deadly and still so alluring, as if the danger itself were part of the appeal, like a flower that only blooms in poison. We won't smell Venus in person for a long time, perhaps never, but that doesn't stop us from imagining it, from building models, from running simulations, from wondering what it would be like to inhale that alien cocktail, even if only through instruments. And in the end, maybe it's not about the smell at all. Maybe it's about what the smell represents. Venus reminds us that beauty and horror can share a single face, that chemistry, when left unchecked, can become destiny, that even in a universe full of stars and moons and cozy little planets, there are places that smell like endings. But for now, she drifts above us, dressed in clouded gold, odorless to our eyes, soundless in our skies, and still softly intoxicating. It began with quiet ambition, a whisper of curiosity wrapped in metal and circuits. While the rest of the world watched the moon, the Soviet Union turned its gaze toward Venus. Not because she was friendly, not because she invited visitors, but because she was there, glowing with mystery in the western sky. The missions were called Venera, which means Venus in Russian. Each one a silent envoy launched into the unknown, carrying instruments, hopes, and the soft certainty that they would not return. Venera 1, in 1961, never even made contact. It flew past the planet, silent and unresponsive. A ghost probe, lost but not forgotten. Then came more. Venera 2, Venera 3, each one a little better, a little bolder. Venera 3 holds a peculiar honor. It was the first human-made object to impact another planet. Not land, not explore, just impact. A brief, blazing moment. A kiss against a wall of pressure. But the Soviets were persistent, quietly romantic in their own way. They kept building, kept launching. Each mission more advanced, each probe slightly more prepared for what awaited beneath the clouds. By the early 1970s, they began to succeed. Briefly. Venera 7 was the first spacecraft to transmit data from the surface of another planet. It didn't last long. The landing was rough. The signal was faint. But for 23 glorious minutes, we heard from Venus. The data it sent was simple. Temperature, pressure, a few vital signs. And yet, it was monumental. A message from a place so hostile it could crush submarines into coins. It was, in its way, a love letter, from a robot to the stars. After that, the successes came more often. Venera 9 returned the first black and white photographs from the surface of Venus. Grainy, stark, a rocky plain under a heavy sky. No vegetation, no movement, just a field of stones under an orange veil. The pictures were not dramatic, but they were real. And that, perhaps, is what made them profound. For the first time, humanity had seen the face of another planet's surface, not in paintings, not through telescopes, but from a camera sitting on the actual ground. Venus revealed, briefly, through static and haze. Other landers followed Venera 10, 13, 14. Each one carrying scientific instruments, each one surrendering to the inevitable. They were designed to withstand the pressure and heat for as long as possible. Most managed just under an hour. Venera 13 holds a special place in the quiet hall of space achievement. It lasted 127 minutes. It returned color photographs. It even deployed a small arm to test the soil. The result, the ground was described as cohesive, somewhere between clay and sand. Not bad for a robot in a volcano. But what made these missions remarkable wasn't just the data, it was the tone. These were not high-drama triumphs like the Apollo landings. They were patient acts of endurance. Launch, cruise, descend, survive. Just long enough to whisper what they found. They didn't plant flags. They didn't carry humans. They didn't return home. And yet, they were among the most courageous things we've ever done. Because Venus does not welcome guests. She cooks them, melts them, silences them. And still, we went. The Soviet engineers knew exactly what would happen. They designed their machines not to succeed, but to endure failure with grace. Heavy armor, pressure vessels, cooling systems designed to delay the inevitable. Each lander was a candle in a furnace, burning as long as it could. There's something gently heartbreaking about that, and poetic too. After the Venera series ended, the world turned away from Venus. The Americans turned toward Mars. The Soviets, eventually, turned inward. But the legacy remains. Today, when we speak of exploring Venus again, with new probes, new technology, perhaps even human missions in the distant future, we still rely on what those early machines told us. Their signals, their photographs, their brief, breathless moments on the surface. They were the first, and they were brave in their own quiet way. In the decades since, other missions have orbited Venus. Magellan from NASA mapped the surface with radar. Akatsuki from Japan watches the atmosphere, trying to unravel its moods, but no one has landed again. It's been over 40 years since anyone touched down. And yet, those little Soviet landers still rest there, somewhere on the glowing plains, half buried in dust, softly melted by time. They are perhaps the loneliest artifacts we've ever created, but not forgotten. Their names Venera 7, 9, the 13th of May not be as famous as Voyager or Curiosity, but their journey was no less extraordinary. They were among the first to reach out, not just across distance, but into impossibility. To say, we are here. To ask, what lies beneath your clouds? And to listen even briefly to the answer. Today, Venus continues to call us, quietly, without invitation, without comfort. And somewhere beneath that swirling yellow sky lie the remains of our curiosity, burnt, pressed, broken, but still, somehow, beautiful. There is a kind of lightning on Venus, or so we think. It's not the familiar flash and boom of summer storms, nor the jagged drama that streaks across Earth's skies. On Venus, Lightning is quieter, slower, a mystery whispered through thick clouds. No eyewitness has ever seen it. No ears have ever heard it crack. But the instruments, those careful, patient listeners, suggest it's there waiting. Detecting lightning on a planet wrapped in acid fog is no easy task. You can't look for flashes through the clouds. They don't part. They don't reveal. Instead, we listen. For decades, spacecraft have tuned their sensors to the static, that soft, erratic hiss that lightning leaves behind. And from time to time, they hear something. Bursts, blips, electric sighs in the darkness. These signals are not always consistent. Some missions hear more than others. Some days are noisier. Some orbits quieter. Scientists argue gently about what it all means. Some say it's real. Others suspect instrument noise. Venus, as usual, offers no clarity. But if lightning does exist there, it lives a strange life. On Earth, lightning dances between clouds and ground, or between clouds themselves. It travels through air charged with tension, fueled by water vapor, temperature differences, and the choreography of wind. On Venus, the recipe is different. The atmosphere is thick, full of carbon dioxide, not nitrogen and oxygen. The clouds are made of sulfuric acid, heavier, denser, and meaner than Earth's cotton puff cumulus. And yet, somehow, the conditions might still be right. It's thought that deep in the cloud layers, as particles swirl and rub against each other, they may build up electric charges, slowly, reluctantly, until eventually they discharge. A flicker, a spark, a flash swallowed almost immediately by the murky sky. No thunder follows. The sound, if it exists, would die inches from its birth. The air is too thick, too stifling for sharp echoes. It's lightning in slow motion. Even if we stood in the clouds suspended safely in a protective craft, wrapped in insulation and caution, we might not see it. The flashes might never reach our eyes. The glow could be muted, soft, more like a distant camera flash behind a thick curtain than the jagged brilliance we know. Still, there's something enchanting about the idea of lightning on Venus. It suggests motion, energy, that even in a place so slow, so heavy, there are moments of sudden brightness, tiny rebellions of charge. Perhaps the planet, in her own way, is not as still as she seems. There's another possibility too, that the lightning doesn't come from the clouds, but from the volcanoes. Volcanic lightning is a real thing here on Earth. As ash and particles spew into the sky, they grind together, creating charges that discharge as brilliant sparks. If Venus is still volcanically active, and she might be, then some of the lightning could be born from those silent eruptions. Not thunderclouds, but magma storms. Imagine that for a moment. A volcano buried beneath yellow haze, erupting in slow motion, hidden from all eyes, but briefly illuminating the thick sky with an internal flash. A spark, a heartbeat. There's poetry in that. Some spacecraft have tried to get closer, probes with special instruments designed to listen for these electric murmurs. Balloons that floated through the clouds, drifting in the currents, quietly recording every flicker and hiss. But the data is messy, ambiguous. Venus doesn't give us easy answers. She offers fragments, clues wrapped in noise, hints. And so the question of lightning remains open, one more riddle among many. Perhaps it's there, flickering above the plains, or perhaps the clouds only almost light up, forever on the edge of a spark. Either way, it adds to the planet's mood. That strange blend of stillness and fury, a place where nothing moves quickly, but where forces still stir beneath the surface, where clouds churn, acids swirl, and just maybe electricity builds in silence. If it exists, Venusian lightning isn't a show. It's a secret, a pulse behind a mask. And maybe that's fitting, because lightning, at its core, is the sky remembering energy. It's a flash of stored tension, a momentary release. And what is Venus if not a planet of stored tension? A world that holds heat, pressure, memory. A world that glows without revealing. We'll keep listening. Future missions may bring better sensors, smarter instruments. They may finally confirm the sparks, or not. The beauty of mystery is that it doesn't demand resolution. And until we know for sure, we can imagine it. A quiet evening on Venus, high above the ground, where a research balloon drifts in golden mist. The clouds swirl around thick as soup, and somewhere, far below, a flash. Soft, sudden, gone. A blink from a planet that rarely blinks. A reminder that even here in this heavy, sulfur-wrapped world, the sky still remembers how to shimmer. It's one of the strangest facts in the solar system. Venus spins backwards. Not metaphorically, not slowly, but literally in the opposite direction from most of the other planets. If you stood above the solar system and watched from a distance, you'd see a stately waltz of spinning spheres, all turning more or less the same way, except for Venus doing her own slow, deliberate pirouette in reverse. It's called retrograde rotation, and no one's entirely sure why it happened. At some point in the deep past, Venus likely spun in the same direction as Earth, fast, to perhaps a day as short as a few dozen Earth hours. But over time, something changed. Her rotation slowed, stalled, and then reversed. Now, a single day on Venus from one sunrise to the next takes 243 Earth days, and it flows in the opposite direction. The sun would rise in the west and set in the east, if you could ever see it through the golden fog. Scientists have theories, of course. They always do. Some believe that early in its life, Venus experienced a massive collision, a cosmic bump from a wayward body, a planetary sucker punch that disrupted its spin and knocked it off rhythm. It's a tidy theory, and possible, but not confirmed. Others suggest the change was slower, more subtle, a kind of long, drawn-out surrender. Over millions of years, Venus's dense atmosphere, full of thick gases and slow-motion currents, may have acted like a giant brake. The sun's gravitational tug, interacting with this vast, sweltering envelope, could have gradually reversed the planet's rotation. Imagine it, an entire world so thick with air that the air itself eventually told it to spin the other way. That kind of atmospheric torque is hard to imagine on Earth. Our air is far too light, our friction too minimal. But Venus is different. Her clouds have mass, her winds have heft, and time, after all, is abundant. It's an elegant possibility, a slow rebellion of weather. Then again, some scientists speculate that Venus might have always been strange, that her backward spin is not the result of a change, but simply how she formed. An original quirk, a cosmic decision made in silence at the dawn of the solar system. Perhaps Venus never agreed to follow the rules. Perhaps she was always inclined to drift against the tide. Whatever the cause, the result is one of the slowest, oddest rotations known. So slow, in fact, that a day on Venus is longer than a year. Not just a little longer, 18 days longer. That's right. The planet takes 225 Earth days to orbit the Sun, and 243 Earth days to turn once around its own axis. It's one of those facts that doesn't feel real, a day that outlasts a year, a world where time doesn't tick so much as ooze. Imagine watching the sun rise, then waiting 8 months for it to set again, only to have the whole process happen backwards. Of course, the clouds make sure you never see any of it. The sky is always the same, thick, yellow, and softly glowing. Sunlight filters in like a light bulb behind a shower curtain. You'd never know the sky was turning. The wind moves faster than the surface, whipping around the planet in mere days, a strange contradiction to the plodding spin of the crust. This phenomenon, called superrotation, adds another layer of complexity to an already baffling planet. It's as if the surface and the atmosphere are two dancers sharing the same stage, but dancing to different songs. The implications of Venus's backward spin ripple outward. It affects tidal forces, climate patterns, and even the way we model potential missions. A spacecraft landing on Venus needs to think differently about day and night cycles, or perhaps not think about them at all. The distinction is meaningless in the gloom. It also affects the planet's magnetic field, or lack thereof. Unlike Earth, Venus has no strong magnetic shield. Its slow rotation is partly to blame. Magnetic fields are often generated by the motion of molten metals deep within a planet's core, driven by rotation. Without a good spin, you don't get much of a field, and without a magnetic field, you don't get much protection from solar particles. Venus, therefore, is naked to the sun, and still, she shines. Perhaps the most enchanting part of this odd rotations is the metaphor it offers. Venus does everything wrong, spins backwards, cooks itself, defies observation, and yet she remains one of the brightest objects in our sky. She's proof that you can be contrary and beautiful, backwards and luminous, in a solar system full of predictable orbits and steady rotations. Venus is the dancer who spins slowly, in reverse, without apology. And maybe that's enough, because in her quiet, smouldering way, she reminds us that there's no one path through the universe, that even a planet can change direction, that time, speed, and spin are not fixed, just tendencies. And somewhere out there, in the heavy twilight of a Venusian afternoon that lasts half a year, the sky continues to turn the wrong way. Softly, slowly, unbothered. To map Venus is to draw a place you cannot see. There are no clear skies, no sweeping satellite photos, no friendly sunlight bouncing off mountaintops. The entire planet is cloaked in clouds thick, endless, and opaque. Not the kind that part on sunny days, but the kind that wrap around a world like a silk shroud soaked in sulfur. And yet, we have maps. Not just crude sketches, but intricate, detailed renderings of plains, ridges, domes, valleys. We know where the highlands are, where the lava flowed, even where the mountains rise like ancient shoulders beneath the haze. How? Radar. Imagine shouting into a fog and listening carefully for the echo. That's how we map Venus, not with eyes, but with ears. Day after day, orbit after orbit, like a blindfolded cartographer tapping the surface with a stick. The result was astonishing. Over 4 years, Magellan mapped 98% of the Venusian surface with high resolution down to about 100 meters. We saw for the first time the ridged patterns of tesserae, the broad lava plains, the strange circular features called coronae, and the elegant folds of ancient crust. And we saw mountains. One in particular, Maxwell Montes, stands out. Rising about 11 kilometers high, it is the tallest mountain on Venus. It gleams in radar images, not because of sunlight, but because its surface reflects radar waves strongly, possibly due to a strange metallic frost formed from minerals that condense in the thinner, cooler air at high elevations. A mountain with its own kind of dew, only on Venus. But radar mapping is more than just height and shape. It reveals texture. Some areas reflect signals like mirrors, smooth, metallic, perhaps volcanic in nature. Others scatter the waves like gravel, hinting at rough terrain or complex formations. In this way, we see Venus not as she appears, but as she behaves. It's like getting to know someone by the way they walk, not by their face. The process of radar mapping is not instant. It requires patience. Each pass reveals a strip of terrain, then another, slowly, piece by piece, like a jigsaw puzzle assembled without the picture on the box. And then there's the rotation problem. Venus turns so slowly and in the opposite direction that building a global map requires careful alignment of data. The planet isn't in a rush to show us anything. We have to wait for the right angles. Later missions refine the maps, but Magellan remains the gold standard. The quiet artist who gave us a portrait of a planet no one can visit. Still, radar has its limits. It can't penetrate deeply into the surface. It can't tell us what lies beneath the crust. It can't detect fine details like the composition of soil or the movement of heat. For that, we need more advanced tools, instruments that have yet to fly. But even with those limits, what radar gives us is enough to imagine, enough to wander softly in the mind, to trace the gentle rise of a ridge, to imagine standing on a lava plain, surrounded by quiet, with a sky the color of old brass, to wonder what it might feel like to walk in a world you've only touched with echoes. One of the most haunting aspects of radar mapping is how quiet it is. There is no noise in the data, no sound in the void, just pulses, returns, numbers, and from those numbers we build landscapes. We've done this before. Earth's own seafloor was mapped with sonar long before anyone saw it. Mars has been scanned with radar from orbit too, but Venus is special. She's the only planet we've drawn entirely blind. Every feature we've charted, every plain and peak, every valley and fracture was rendered from signals bounced through poison. It's a strange kind of intimacy. To map a place you cannot touch, to know the folds of a planet without ever seeing its skin, to dream of a landscape built from silence. And when you look at a map of Venus with its softly named regions like Lavinia Planitia or Ishtar Terra, you see more than terrain. You see imagination, patience, the gentle persistence of curiosity. A world rendered not in light, but in radar. A place made visible by listening. And beneath it all, still hidden in cloud, still warm and quiet, the real Venus waits unchanged, unmoved, unmapped by eyes. A world that lets us know her only by the way she answers back. Venus is not known for being accommodating, but like all complex characters, she has her contradictions. In between the scorched rock and the molten sky, there are places, or rather, altitudes where things get strangely calm. Hover about 50 to 60 kilometers above the surface, and you'll find a narrow band in the atmosphere where the pressure and temperature are quite astonishingly not too far from Earth's. Not comfortable, certainly, but survivable with the right suit, with the right ship, with a little imagination. This region, sometimes referred to in speculative circles as the habitable zone of Venus's atmosphere, is an atmospheric balcony suspended high above the inferno belows. The temperature here hovers around 20 to 30 degrees Celsius. The pressure is close to what we experience at sea level on Earth. Of course, the air is still pure carbon dioxide, and there's sulfuric acid mist, and the occasional lightning bolt that may or may not exist. But in the realm of Venus, this counts as luxurious. So naturally, someone had the idea. What if we lived here? Not on the ground, not beneath domes, but floating, like cloud ships in a steampunk dream. Enter the concept of aerostat's floating cities, held aloft by great envelopes of gas lighter than the thick Venusian atmosphere. On Earth, helium or hydrogen gives lift in our thin, nitrogen-rich air. On Venus, where the atmosphere is heavier, the same gases provide even more buoyancy. A balloon full of breathable air, in fact, would rise automatically on Venus because air, with its mix of nitrogen and oxygen, is lighter than the CO2-rich atmosphere. It's an odd inversion. On Earth, we build habitats to keep air in. On Venus, we could build them to keep air up. The design sketches are quietly whimsical. Domed structures hanging beneath gas bags, braced by struts, with solar panels spread like wings. Windows would show nothing but haze. Below would be an endless sea of clouds. Above, a dim golden sky. No ground, no land, just altitude. Floating there in the upper clouds, life would be challenging, but not impossible. Solar energy is abundant. Venus receives nearly twice as much sunlight as Earth. The air outside wouldn't need extreme pressurization. Thermal regulation, while still necessary, would be far easier than on the surface. It's the kind of place where scientific stations could be built, perhaps one day, even homes. Of course, sulfuric acid remains an issue. The clouds are laced with it, but materials exist: Teflon, certain plastics, ceramics that resist corrosion. We know how to build acid-proof vessels. We've done it before, though never on this scale. And then there's the wind. Venus's upper atmosphere races around the planet in a matter of days, even as the surface takes months to turn. This superrotation means that a floating station would circle the planet every 4 Earth days or so. A fast-moving platform in a slow-spinning world. From that vantage, the light would change slowly, filtered through ever-thickening clouds. Day and night would blur. There would be no stars to see, no blue sky, only gold and beige and deepening shadows. Would it feel like home? Perhaps not at first, but humans are good at adjusting, at shaping strange places into something familiar. We once built homes in deserts, tundras, on islands made of coral. We've adapted to high altitudes, to jungles, to life aboard submarines. Venus would be extreme, yes, but not unimaginable. In this high perch, floating in the acid-scented breeze, perhaps we would build greenhouses, labs, shelters filled with filtered air and quiet machines. Children might grow up thinking the golden sky was normal. Adults might sip tea in gravity almost identical to Earth's, listening to the muffled hum of wind against the hull. And maybe, every now and then, someone would glance down through a porthole and wonder what lies beneath. The surface, of course, would remain unreachable, a reminder, a warning, a glowing exile. But up here, in the clouds, there would be life, observation, hope, and maybe, eventually, beauty. The idea of floating cities is not new. Science fiction has toyed with it for decades, but on Venus, it feels almost plausible. The physics check out, the materials exist. The only thing missing is time, investment, will. But dreams, like balloons, require lift. And there's something deeply human about dreaming of life where none should exist, of building in the sky, of finding peace above chaos. Floating cities are not an answer to every question Venus asks. They are not escape hatches. They are not proofs of dominance. They are acts of imagination. And that, perhaps, is what Venus has always offered us: not welcome, not warmth, but a kind of invitation to wonder, to reach, to try, to say, what if? Even now, she gleams in our evening sky, not closer, not softer, but there. And we, in turn, imagine domes drifting high above her storms, catching sunlight, resisting acid, full of breath and stories. Not because we need to be there, but because we can dream of being there. Maxwell Montes is not a name that often stirs the imagination. It sounds more like an old professor than a mountain. But on Venus, Maxwell Monte is the highest peak, a lonely ridge rising some 11 kilometers above the smoldering plains. It is, quite literally, the rooftop of a planet that doesn't want visitors. You could not climb Maxwell Montes, of course. You could not hike its slopes or plant a flag at its summit. The heat alone would melt the soles of your boots before you took a single step. The pressure would squeeze your lungs into silence. And the sky above? Still yellow, still unforgiving. But in the slow, poetic style of radar, we have seen it. It sits in a region called Ishtar Terra, a highland near Venus's North Pole. Named after the Babylonian goddess of love and war, Ishtar is home to Maxwell Montes, as well as a series of broad, gently folded structures called tesserae, like cracked pavement laid by a planetary hand. Tesserae are among the most complex and ancient features on Venus. No one is entirely sure how they formed. Their ridges and grooves intersect like stubborn lines on weathered skin. They seem to suggest compression, shifting, upheaval tectonic stories told in whispers. Maxwell Montes cuts through this old terrain like a spine. It's bright in radar images, meaning it reflects well, perhaps due to rough surfaces, or perhaps due to unusual minerals. Some scientists suspect the peaks are coated in a kind of metallic frost, not ice, something stranger. Galena, perhaps lead sulfide, or pyrite fool's gold, minerals that condense in Venus's cooler upper altitudes, forming a thin crust on mountaintops that never see the stars. There is something quietly majestic about this image, a golden mountain capped not in snow, but in glimmering metal, a summit never seen by eye, never touched by wind, preserved in silence. Other features nearby are equally strange. There are the pancake dome circular, flat-topped volcanic formations, some tens of kilometers across. They rise gently, like batter poured onto a skillet, hardened into shape by the searing air. These domes are found mostly in the lowlands, but their presence speaks to the planet's volcanic past, and perhaps its volcanic present. They suggest thick lava, oozing slowly, unable to travel far before cooling into soft, bulbous mounds. Some are stacked, some are solitary, all are still. Elsewhere, we find rift zones long, stretched valleys, where the crust seems to have been pulled apart. Not as dramatic as Earth's great faults, but visible nonetheless. The planet, though lacking plate tectonics, still shows signs of strain. She's moved, she's breathed, she may still be breathing. To walk across this terrain, if you could, would be unlike any trek on Earth. There would be no sky above, just cloud, no birds, no breeze, just stillness and heat. The ground would feel soft in some places, hard in others, cracked, uneven, burnt, and yet quiet. No rivers carve these valleys, no glaciers smooth these plains. Everything you see would be the work of pressure and fire, of rock shifting under heat and time. A landscape without water, without erosion, only collapse and eruption. Even naming these features carries a kind of reverence. On Venus, geological formations are almost exclusively named after women, goddesses, pioneers, mythological heroines. It's a quiet counterpoint to the harshness of the surface, a soft naming of a hard world. Fredegonde crater, Cleopatra patera, Akhmatova corona. Names whispered across lava, tributes from afar. And though we will likely never hike these slopes or run our hands along these ridges, we know them. We've mapped them, measured them, grown fond of their peculiar shapes. Because to study a landscape like Venus's is to imagine it. To look at a radar map and picture the slope of a valley. To see a bright spot and wonder, is it metal? Is it just rough? What does it feel like to stand there? Venus does not make it easy. She hides everything behind sulfur and heat. But still, she reveals enough to let us wonder. And perhaps that's the most poetic part of all. That a place so distant, so deadly, so utterly unwalkable, could still inspire geography, still draw lines on maps, still earn names and stories and quiet awe. Maxwell Montes will likely never host a base. No climber will leave footprints in its mineral frost, but it stands unmoving, unwatched beneath a sky that never clears. And somehow, that's enough. A mountain that doesn't need to be seen to be known. Thank you for falling asleep with Sleep Library. Venus will keep spinning backward, with or without us, and we're glad you joined her, even just for a while. If you'd like more quiet stories like this, you're warmly invited to subscribe, and we always love seeing your comments, even the half-asleep ones. Until next time, rest well.